Okay. Implicit differentiation. Uh, Today I will be focusing on the shortcuts used in doing implicit differentiation. So, but before then, if you could remember, if they give you a constant, if you differentiate a constant, is always zero. So, in general, if you are given an implicit function, maybe f of xy equals to a constant, as an implicit function, to find the dy dx is always equal to minus partial x over partial y. That is, differentiate with respect to x only. That's the meaning. Y is constant. Y would differentiate y only. Here, with respect to y only, yx is a constant. So that's what I'll be using here. So as you can see, the first one, dy over dx is now minus, if you differentiate this with respect to x, so y is now a constant, differentiate x squared is 2x over, we are done with that. So we differentiate with respect to y, we have 2y. You know, when differentiating with respect to x, y is now a constant. If you differentiate a constant, is 0. So that's why it's plus 0. Let me write it plus 0. So our answer is minus x over y. So do you see it's very fast? Why the second one? Minus, we differentiate, this is now 2x plus 0 plus, remember, y is now a constant, so we keep 3y's like a constant now. So if you differentiate x1, so we have 3y over that same logic. If you differentiate with respect to y only, so x is constant. If you differentiate x with 0 plus 2y, now our constant is like 3x. So if you differentiate, y is 1, so our answer is 3x. Therefore, the derivative is equal to minus 2x plus 3y over 2y plus 3x. So I think it's very fast. So why the last one? Dy dx is now minus, that's chain rule. So if you differentiate, okay, first of all, we need to move this to the other side. So this is like c, it's like sine x cubed plus y squared minus x squared equal to 0, so that it will look like the function. So that's it, equals to a constant. So we now start minus, if you differentiate sine, you have cos, so cos x cubed plus y squared times the derivative of inside, as I'm applying power rule in chain rule. That's chain rule, shortcut to chain rule, so times the derivative of inside here. Now that's where the partial x plays a role. If you differentiate x cubed is 3x squared, while this is 0, so we have 3x squared minus, remember, if you differentiate x squared is 2x. So we are done with the numerator. We move to the denominator. So that same logic, if you differentiate sine, is cos s cubed plus y squared times, because the derivative of inside is 2y, because x is now a constant, so that's the derivative of this, minus 0 So the final answer is so let's move to the next line. Okay, so let's simplify. This is minus times this. Okay, we'll write this as 2x minus 3x squared times as cos times cos s cubed plus y squared over it's now 2y cos x cubed plus y squared. So that's our answer. So this method makes it very simple. Instead of doing that long process using partial derivative. So that's the key. This is the key. So I hope it helps. Thank you.